Hi, welcome to my next lecture. Today we're going to see congruence of triangles. Congruence is an interesting concept. Let's see how we apply that to triangles. In the picture, I think you can see two triangles. I tried to write them as much similar to each other. The word congruence actually means both are similar. When you apply that to triangles, it's largely what we mean is all three sides of a triangle are same. For instance, right, AB here in triangle ABC, side AB length is same as side DE, side DF is same as like AC, and side BC length is same as this one. Also, it doesn't mean just sides being equal. Congruence also means all three angles are also equal. What does it mean? So it means that AB is equal to DE, EF BC is equal to EF, and AC is equal to TF. And it also means angle ABC is equal to angle DEF. Similarly, all other angles are also equal. This particular angle BAC is also equal to angle EDF. And the other angle EFD is also equal to BCA. So all three angles and all three sides are equal. So when this happens, you call like both triangles, triangle ABC and triangle DEF are congruent. And congruency is determined by a new symbol. It's equal to, on top of it, like there is a kind of S, inverted S. Then we can say both triangles are congruent. It's difficult, I think, looking at it and figuring out like all three angles and all three sides are equal or not. So what people have devised here is there are certain rules that they've said. We'll look into the details of each of the rules and then say like, I think why the congruence is like that, why the congruence is the other way around, right? One simple test that I want you guys to actually do is cut out two triangles almost similar in shape, like make sure that the angles and what you call sides length are same. The easiest way to just in two physical objects, whether they're congruent or not, is placing them one over the other. Take two triangles, place them one over the other. If you don't see any extra region, then you can say that both these things are congruent. And that's a simple step for congruence. Now, is it required that all three sides and three angles are equal? Technically, yes. I think congruence by definition actually means that all three sides and all three angles are equal. But there are also some rules that people have devised. Hey, you don't really have to do like all these things, right? So what are those rules and what are the type of congruence that we actually have? Let me take what you call a different color. There are different types of congruence that are rules that are defined. So you don't really have to check like I think three sides. You can check like three sides and three angles. You can just check some of the rules that I'm going to tell here. There are different types of congruence. One is SSS, right? We'll look into it a little later. SAS, right? And ASA, right? And there is a derivative of it, like it's called RHS. So if these are true, like you don't really have to measure three sides, three angles and everything, then people figured out that, like I think if at least these things are true, then the other three have to be same. So what are those? We'll look into it. Let's look into it one by one in detail. Let's take SSS as a first congruence thing. So in case of SSS, what happens is, what we are trying to say here is, let's take two triangles, ABC and DEF again, C and DEF. If all three sides are exactly same, remember, like I think it doesn't mean all three sides are equal to all three sides. Like all three sides of a triangle, it's not an equilateral triangle, it need not. So this side is same as this side is same as the other side, and this side in particular is same as this side. If this is the case, then we say that it's a congruent triangle. Why? You might have seen an isosceles triangle, right? So what happens? Two sides are equal, then opposite angles are also equal. Exactly the same thing happens. If three sides are equal, their angles will be in the ratio of their sides. So it should happen that like angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. So it is not necessary that you measure all three other three angles. They will be same. Right. SSS says that if just sides are of same length, then angles have to be equal. So you don't say angles are equal. Then that is good enough for us to say that the triangle is congruent. Now, one of the interesting exercise for you is take three different lengths. Let's say this is 5 centimeters, this is 4 centimeters, this is 6 centimeters. Now, can you create a triangle which is not congruent to it? The answer is no, but it's worth understanding and actually trying these things so that the concepts are crystal clear to you. The next type of congruence that we have is called SAS. Let me switch the color so that you will understand it better. Now, remember letter V, right? So A, B, C again. So now what SAS says is you just have to remember letter V and D, E, F. Here we have two triangles, ABC and DEF. Again, this is A1, this is A1. This says that if two sides are equal, right, and their included angle, it doesn't mean like angle D is equal to angle BA, like then probably these are not congruent. We don't say like that. What we say is always remember for SAS, V, letter V, and the angle has to be somewhere in between. Now, can we try, like I think, let us say if two sides are equal in a V and angle is also equal, which means that we also draw like I think another two sides equal and angle is equal. Because the length are same, you cannot construct any triangle which is not congruent. And that is the reason why SAS says that we just need to figure out like I think two sides and included angle is equal. We cannot construct a triangle which is not congruent to the initial triangle. And that is the minimum criteria that we need to say that both triangles are congruent, and it is represented again by ABC, which is congruent to what you call DEF. All right. Let's add another page for the other type of. The third one is ASA. So what is ASA congruence? Here it is the other way around. Like what we say is in a triangle ABC, two angles and an included side. Suppose this angle is A1 and the angle is A2 and an included side is BC. Now let's construct another triangle DEF. So this is also A1, this is A2, right? So the whole point is like if you keep the angles same, how do you construct a triangle, right? If you keep the angle same, it is likely that you will not be able to create any other triangle which is different from the original triangle. And that's what that rule says here. Suppose if two angles and an included side, right, are same, then we can say that these two triangles are congruent. Congruency by definition, actually, I'm repeating, congruency by definition says that all three sides, all three angles should be equal. But because people figured out that the congruence is implied, it need not do all six things. So if it does any one of these, then it is easier for you guys to actually remember. Now, next one is, as an extension, is RHS. So in a right angle triangle, so if right angle, ABC is a right angle triangle, right angle and hypotenuse and side, hypotenuse and one of the side, right, is equal, right? Then I think people say that like I think both triangles are congruent. It's a derived what you call extension of like I think ASA property or like SAS property. So you'll see how like in a right angle triangle, like if hypotenuse is same and also if what you call one of the side is same, like let us say one of the side is same, it should happen that like why it should happen that like because if hypotenuse and side are same, this side of the both triangle has to be same, because you have seen Pythagoras theorem, h square is equal to s1 square plus s2 square, assuming that s1 is this and s2 is this. So if two entities in an equation are same, the third also has to be same. So it becomes an extension of like I think we don't even need a right angle. It becomes SSS also. We can prove that using SSS also we can prove if two sides of a right angle triangle are same, the third side definitely has to be same because by Pythagoras theorem, hypotenuse square is equal to one side square plus other side square. So what people are saying is like, I think this is not, RHS cannot be actually seen as a completely new rule. RHS is also an extension of, if you ask me, is a similar type of SSS because if two sides are same, because in right angle triangle, the third side is nothing but what you call difference of squares and the square root of, like, I think, let's say S2, if you want to find, is always same as H1 square minus S1 square in the square root. Right. So this value for these two will be same if these two are same. So what is the criteria? The criteria is that it should be a right angle triangle. So the most important thing that you learned is in congruence, it is congruence means all three angles and all three sides, these sides have to be same. But to prove congruence, one of these rules are enough. What are these? S, 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 all three sides, S, A, S. If you see in the acronym itself, like they have put angle in between two sides. So it's easier for us to actually remember, right? ASA, two angles and a side in between, and RHS, right angle, hypotenuse, and side. So there is also one more thing that people say. SSA, or like is SSA is people have given, like I think if two sides are same, right, their opposite angles have to be same because it is like happiness, but it is not required. You probably can use triangle properties and actually say everything as a part of like one of these rules. Suppose SSS, SAS, ASA, and RHS. These are the only things that you need to remember. I would also recommend you to actually make some kind of a flashcard. Right. What we have learned, like to summarize, we said that congruence means like all three sides and all three angles have to be same. We also check like different types of congruence, SSS, SAS, ASA, and RHS. Right. One way to quickly cover and revise things faster so that you don't forget these things is the best way to do, in my opinion, is by creating a kind of a flashcard for congruence. Right. You can create a card like this. It can be made out of chart paper so that it can last little longer. Maybe it will come one entire year. You can say congruence. uh, so one of the technique here is when you're making your card, uh, our brain remembers visual items more than actual what you call text. So it's important that like when you're writing a side congruence, let us say, you actually use visual cues there, like to draw maybe in a different color, if that actually helps. So that it registers in your brain and you don't really have to study a lot about the congruence any time in the year. So right angle hypotenuse side, like you can actually represent like this. You can put SSS here. You can put ASA for SAS. I always remembered that using a V and an angle. So V is not a triangle, but this is easier for me to actually recollect. But do make sure that you guys actually try to challenge the norm and say that why SAS is there. Like, can I take a V and actually create the same angle? Let's say two V's. Can I create a triangle which are not congruent? And that is the best way to understand congruence of triangles. Hope you like my video. I think, and cool.